why all of a sudden is the explosion of ChatGPT and Gemini and, you may not know, but I'm asking all the AI people I've spoken to, what do you think did it? Why was there a tipping point in 2023?
Well, I think that there's a few things that kind of converged at that time, right? So, most of the work that I had done was in sort of the deep neural net work, right? So mainly in computer vision. So how do we use large labeled data sets to train models to do given tasks, right? And a lot of those things in healthcare, there's plenty of examples, but obviously that there was an entire, many decade history of AI before that too. But in fact, the convolutional neural network was first described in the 80s, by the way. But it wasn't until a few factors kind of came into focus, right? So the first being compute, right? Moore's law. For a long time, you just simply didn't have enough horsepower, right, to scale these things up. I think the second big piece was data, right? So you needed to have large quantities of, in this case, digital data at scale. And then I think the final piece was like, what's the best algorithm to learn patterns in large amounts of data? And, there was lots of different versions of this, right? So, go before GPT, we were exploring all kinds of things like LSTMs and RNNs and all kinds of other ways to, in the text and obviously the imaging space, both. But there were some sparks that I think when you look back would have better prepared us to predict this moment. I think the first, of course, is that people may know is AlphaGo, right? So this idea of having the model train itself, right? Sort of self-supervised learning. And then the transformer paper, which was around 2017, which is an architecture that is incredibly convenient for scaling. And so all those factors kind of started to blend together, tons of data, really convenient and powerful compute. And then this architecture that's incredibly modular and scalable and able to be self-supervised in terms of how it can be trained. And so I think that, there are lots of different versions of this, but the folks at OpenAI were some of the first to really take that transformer architecture and really scale it up on, internet-sized data sets with massive amounts of compute. And really the goal was to predict the next word. You show it a sentence and you mask out a word, and then you ask it to predict what word was masked out, right? You do that over and over and over again, just like with the AlphaGo experiment, where you just play the game over and over and over again against yourself, right? And eventually you learn patterns, or what we call representations of the information, how it was constructed. And, some folks in one camp believe that internal representation has meaning beyond just the data itself. And then others would argue that it's only learning a certain distribution and can't quote unquote generalize or do things outside of that. I tend to be in the former camp, but nonetheless, those are the ingredients really that got us to this point. There's some other things too, but those are the main ones.
So more data, more layers in like let's say in a neural network, and now novel training methods, and suddenly we're getting this emergent behavior that's working much better than it used to.
Yeah, and the emergent behavior thing is a very interesting topic, because what you're referring to there is that, okay, so how do we judge how these models are getting better, right? Like, so we have to have tests or benchmarks to do that. And, there's been lots of benchmarks around forever, certain tasks like identifying or classifying something or translating the, English to Spanish or whatever. There's all kinds of different benchmarks. And what you saw as these models were scaled to really sizes beyond, what folks even thought were reasonable, they were blowing away these benchmarks, but it seemed very sudden, right? It seemed like they were just all of a sudden, boom, it's saturating a benchmark. And that is true, right? They have saturated a variety of benchmarks. At the same time, we sort of feel like it just kind of emerged out of the ether, right, when we talk about it. But ultimately, if you really look at the benchmarks themselves, they're very binary, right? So you either get it right or you get it wrong. And so flipping something from 0 to 1 for a large percentage of the questions, for example, will make it seem like, wow, it popped out of nowhere. It's all of a sudden able to do all these things. Whereas in reality, if you had a more granular, and there's been a few papers on this, sort of looking at that 0 to 1 flip, there's actually a bit more of a gradient there. In other words, there's some more nuance to how these models improve. But what's key to know, I think, for why we're all investing and thinking about this and scaling further is there's something called the scaling laws, right? Which you may have heard of, or may have heard of this anecdotally referred to as like sort of the chinchilla paper from Google. But really what this boils down to is that there's these three core ingredients in the pre-training stage, right? You've got, like we said, compute, you've got data, and you've got parameters, or the number of layers, as you point out, or the size of the model. Now, those three ingredients to make this cake, what they were able to show is that for exponential input in each of those ingredients, you get a pretty smooth linear improvement.